The integral that you end up with is as follows. The integral from 0 to 5, 125 times 7 minus y times the square root of 25 minus y squared dy. Okay, let's talk about how we're going to split up this integral. It looks kind of complicated, but we can really break this down. What we're going to do is we're going to multiply it out, and when we multiply it out, we're going to get something that looks like this. You're going to bring 125 on the outside, the integral with bounds 0 to 5, 7 times the square root 25 minus y squared dy minus 125, the integral with bounds 0 to 5, y square root 25 minus y squared dy. To make this simpler, I'm going to evaluate both integrals separately. So let's call this integral 1 and this one 2. Starting with 1, we're going to have 875 on the outside when we bring out the 7. Integral with bounds 0 to 5 times the square root 25 minus y squared dy. Looking at this, we know that our method of integration will be trig sub. So knowing that we're going to be doing a trig sub, we're going to substitute 5 sine theta for y, and our dy is going to be equal to 5 cosine theta d theta. When we do our substitution, we're going to have 25 minus 5 sine theta squared under the root. When we evaluate that, it's going to look like this. We're going to factor out the 25 to have it look like a trig identity that I think we're all familiar with. We know that 1 minus sine squared theta is also equal to cosine squared theta. If we take the square root of this, we're going to end up with 5 cosine theta. Now back to the integral. So we have 875 times the integral. I'm going to ignore the bounds. We'll worry about that towards the end. Anyways, so we're going to have 875, the integral of 5 cosine theta times, not forgetting that dy is equal to 5 cosine theta. We're going to plug that in, and we end up with, after bringing out 5 times 5, we're going to end up with 21,875 times the integral of cosine squared d theta. Okay, so we end up with the integral of cosine squared d theta, which we already know how to integrate. We're going to use the half angle to rewrite cosine squared theta into something that's easier to integrate, so to speak. So we'll have 21,875 times the integral of 1/2 times 1 plus cosine 2 theta d theta. Now we're going to bring out the 1/2 outside of the integral. Once we do that, we're going to have 21,875 divided by 2 times the integral of 1 plus cosine 2 theta d theta. Time to integrate. When we integrate this, we're going to end up with an answer that looks like 21,875 divided by 2 times theta plus 1/2 sine 2 theta Before I move on, I want you guys to realize that you have 1/2 sine 2 theta. How else can we rewrite this? The double angle theorem. When we rewrite it, it's going to be 21,875 divided by 2 times theta plus sine theta cosine theta. And this was because of the double angle, which we know to be 1/2 sine 2 theta equals sine theta cosine theta. Remember this. It'll make your life a lot easier. Now I want to switch everything that's in theta in terms of y in order to make plugging in the bounds easier. So when I write everything in terms of y, I'm going to use everything that we did before. I'm going to recycle. So sine theta, we know from before, well, 5 sine theta is equal to y. Solving for theta, we're going to have theta equals to sine inverse of y over 5. Now we can do almost the same thing to solve for sine theta. Sine theta is just going to be y over 5. Now to find cosine theta, recall that 5 cosine theta is actually equal to our root, 25 minus y squared. Now we just solve for cosine theta, and we're going to be left with cosine theta equals the square root of 25 minus y squared over 5. When we plug all this back into our final answer, we're going to have, let's call it I1 equals to 21,875 divided by 2 times sine inverse of y over 5 plus y times the square root of 25 minus y squared over 25. All evaluated from 0 to 5. Now when you plug this all into the calculator, you're going to get an answer that looks like this, 17,180.58482. So you thought you got away, but don't forget that we have this second integral to deal with. So let's deal with it right now. As you can see, it's a lot easier. I want you to recognize that you have 25 minus y squared on the inside, and on the outside you have a y. If you'd use a u sub, where your u is going to be 25 minus y squared, and your du is going to be minus 2y dy, you'll see that the y's will cancel. Here's what it looks like. Let's forget the negative sign for a second. You're going to have 125 integral from 0 to 5 of y times the square root of u times du over negative 2y. As you can see, the y's will cancel. And when you clean it up, it'll look like this. Negative 125 over 2, the integral from 0 to 5 of the square root of u du. When we integrate this, you're going to get something that looks like this. Negative 125 over 2 times 2/3. Now plugging back in our u, 25 minus y squared to the 3/2 power. All evaluated at the bounds, 0 to 5. I'm going to skip some details again, but when you plug it into the calculator, you're going to get 5,208, positive 5,208.333, and it goes on. Which, don't forget, you subtracted integral 2 from integral 1. So your final answer, after subtracting the two values that we found out, we're going to have 11,972.25152 pounds. Wasn't so messy after all.